Now I'll do this one more slowly, and unfortunately you have to do log with it. There's no way around it. So we're going to take log of both sides. The reason you have to take a log is because 9 and 4 don't share any compatibility easily in your head that you could come up with. I can't convert 4 to something that has a similar base as 9. 3 and 2 don't have any meeting points when I keep squaring them or cubing them or any exponent, which means I have to take a log of both sides. And you can take a ln of both sides. It doesn't matter. You can take a log of base 2 of both sides, log of base whatever. We'll make our lives easier if we can. So that means the rule of logs is I can move that in front as a multiplier. Great. One thing I don't like is having this fraction, so I would rather just get rid of it now and multiply everything by 2. That's just me. It's going to make my life easier. So I'm going to multiply 2 on this side. It's going to cancel. But that means this 2 over here either has to multiply this bracket or this log and eventually has to get distributed through. But it's a lot easier to have something on the numerator than the denominator. Well, let's multiply that through. I get 6m plus 2, all in a bracket. It's important to keep your brackets because it's got to distribute through log of 4. But log of 4 is just a number. Just remember that. If this was base 2, the answer would be 2. But if I make that log 2 on that side, I would have to make it log base 2 on this side, and there is no easy answer for that. But you know what? Maybe we want to get rid of that, make our life a little easier and use log base 2. In the meantime, I'm just going to keep it log, and we're going to come back and see if it comes out easier with base 2, and I'll try to do it fast. So here I just have m times this. Now we're not going to divide by m because that just leads to a whole bunch of problems, because over here, while there is an m here, it's being added to 2, so I just end up with 2 over m again. Now instead, I'm going to distribute this through, and that's maybe it would have been easier to turn that as log base 2, because I get this 6 plus 2 log of 4 when I distribute it through. I like to have my numbers in front. Doesn't matter when things are multiplying. So there we go. Now I'm going to get this to the left side by subtracting it from both sides. When I subtract it from the right side, it disappears. Now I'm going to get this to the right side. It's being added. Everything's being added and subtracted. So I'm going to get rid of the whole thing by subtracting it on both sides. Why? Because it doesn't have an m in it. It's just a number. I don't need it. It's going to disappear. Now this is what I wanted. My two terms have an m in it. I can factor out that m. And I get a number minus a number in this giant bracket. Well, I can divide both sides. This is just multiplying my m now. I can divide both sides by it. Clearly on the left, it's going to cancel out with the bottom because it's multiplying m. I can do that. And I'm left with this. M is equal to this times that. And that's the exact value of m. You could punch it into a calculator and substitute it in. You could even throw it in for m here into the formula and expand it and see what happens. You could even throw it up here and figure out what happens. But you'd still have to take a log to bring it down. But this is the mathematical way. I didn't make any mistakes. That's the correct way. It is one of the more complicated questions because you have to understand logs. But let's go back to this point and say what happens if I take a log 2 of this, just to make my life easier, because it's distributing through this 3m plus 2. So I'm going to make it a log base 2. And that means that exponent can go up front. And this one, when I take it, the reason I don't do log base 3 instead is because there's a distribution on the left. So maybe it's easier. This is still a legitimate answer because it doesn't matter which log you take on both sides. There you go. So that means this is log 9 over here. But I'm going to, if I take a log 2 on the left, I must take a log 2 on the right. That's the only thing. Well, the answer here is a nice, easy. You know what? I'm going to make my life easy, even easier. Take log base 4. Because the answer on the left here is just 1. What do I put over 4 to get 4? I get 1. So that just becomes 1. So that might make my life easier because now I'm left with this. I just had to make sure I do log base 4 over there. Well, I'm still going to multiply everything by 2. It's going to disappear on the right. Also keep in mind that this is in brackets. So I'm going to do 6m plus 2 is equal to m log base 4 of 9. Just got to try to remember that that's log base 4, not a multiplier. I still have to subtract m from both sides. M log 9 from both sides. So what am I doing there? I'm going to make a bit of room here. I'm subtracting this from the right side, which means I also have to subtract it from the left side. When I subtract it on the right side, it becomes 0. There we go. Now I see I have this 6m plus 2 minus m log 4, so I'm going to subtract 2 from both sides. Okay. And that gets rid of my 2. Now I can see that both these things now have, it's a little bit cleaner. Both these things now have a m in them, so I can take the m out. I get 6 minus log base 4 of 9 is equal to minus 2. A little bit easier. Remember that this is log base 4 here. There we go. Now this whole bracket is multiplying the m, so I'm going to divide the whole bracket on either side. That means m is equal to minus 2 divided by 6 minus log base 4 of 9. A little cleaner. Makes my life a little bit, that's probably more accurate, probably a better way to do it.